Hey guys, welcome again to the Maths Club. If you are just joining us, you're welcome. If you have not subscribed, please smash that subscribe button and don't forget to like this video at the end if you found it useful. So we'll be continuing our series on set theory and we're looking at types of sets. In the previous video, we already introduced the universal sets and subsets. We're going to be looking at all the other types of sets. The first type of sets we'll be looking at is called the equal set. What does it mean when we say two sets are equal? So two sets are equal if they contain the same elements. A good example is, look at this set A and look at set B. If I want to list out the elements of set A, I will say the elements are 2, 6 and 8. If I want to list out the elements of set B, I'll say the elements are 2, 6 and 8. So you can see, because they contain the same elements, it is called an equal set. The second type of set we're looking at is called the equivalent set. What are equivalent sets? These are sets that contain the same number of elements. So if you count the number of elements in set A, you count the number of elements in set B, and they're the same. What will you say? The two sets are equivalent. Look at this now. So you can see this is 1, 2, 3, 4. These are 4 members of this set, and these are also 4 members of this set. And you can see there's a kind of 1-to-1 mapping. So I can map this one to 1, this one to 1, this one to 1, this one to 1, right? That shows that they are equivalent in nature. A warning: an equivalent set is not necessarily an equal set, because the elements in equivalent sets can be different, right? If you look at that previous example, we had 1, 2, 3, 4 and we had A, B, C, D. They were equivalent, but they're not equal because they may contain different elements. But on the other hand, equal sets are always equivalent. And that makes sense, because if the element in a set A is the same element in the set B, remember, equal sets, they must contain the same number of elements, and then they must contain the same elements. So therefore we can say that equal sets are always equivalent. Now the next type of sets we're looking at is the finite set. When we say something is finite, what does that mean? That means that's like a termination point, right? So that explains a finite set, which is a set whose elements can be counted. So once you can count it, right, you can look at all the elements, you can count them, you know they're dealing with a finite set. A good example is the sand in a beach. I mean, you could look at it and say, oh, how can we count the innumerable number of... No. You can actually count the sand. If you want to punish somebody, just tell the person to go to the beach and start counting the sand that is there. But even all the sand on earth has a particular amount, right? It's just almost seemingly impossible to count, but it is very possible to count it. I think if you want to count them, we'll be mostly using maybe the mass or something like that just to get the number. So if you're looking at infinite sets, infinite, meaning that it is still infinity. And let's look at what it says. An infinite set is one whose elements cannot be counted, right? So if you look at it, this is like, this n is like the set of all the real numbers, right? I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1 billion, 1 quintillion. It goes on and on like that. So the next type of sets we're talking about is an empty set. From the word empty set, what does that mean? It means that there is nothing inside. So if you look at empty sets as sets with no items or elements in them. Another name that we call empty sets are also called the null sets. Null, N-U-L-L. And empty sets are always denoted by this phi sign or empty curly brackets, right? There's nothing inside. We said we represent sets with curly brackets. So if there's nothing inside the curly brackets, it's an empty set. So you see this phi sign. So you can see, look at this guy. We have 1, 3, 5 in set X, 2, 4, 6 in set Y. Is there anything common in both of them? No. So if I wanted to find what was common in both of them, we'll look at that very soon in the next video. But if we want to find what is common in both of them, it will be an empty set, because there is nothing common in both of them. Now, the next type of set is called Singleton Set. When they say something is single, it means that there is no couple. So these are sets that contain just one element. Just one element. A good example is B, right? B, who is B? B is a person X, such that X is the queen of my heart, right? There are no queens of my heart, there's just one queen of my heart, right? So if I wanted to represent in terms of sets, we're still going to look at this kind of notation, but it's read that X, B is X, such that X is the queen of my heart. Since there's only one queen of my heart, it is a singleton set. Disjoint sets. When we say something is disjoint, that means that there is no connection between them. Nothing is joining them together.
So two sets A and B are said to be disjoint when they have no elements in common. A good example is set A and set. The elements of set A is A, B, C, D. The elements of this one is Sunday, Monday, Tuesday, Thursday. There is nothing that is joining two of them together. So that is an example of a disjoint set. On the flip side, non-disjoint sets are sets that really have things in common. It could be one thing, it could be two things, it could be at least one element in common. So you can see this guy. I mean, if you look at this set C and this set D, this set elements in sets is 3, 5, 7. The elements in this is 9, 7, 11. Because they have 7 in common, this is a non-disjoint set. And all these things we are looking at, this is actually how we represent Venn diagrams. Even though I'm introducing them now, we are still going to really touch on them in subsequent videos. So just follow through. And with this, we've come to the end of the types of sets. So there are other types of sets, but this is like one of the most common types that we see in mathematics or in everyday use. In the next video, we'll be looking at basic operations involving sets. Operations such as union, intersection, complement. See you in the next video.